Hello, all, and welcome to an exciting video lecture in engineering mathematics brought to you by your instructor Srinidhi from the Bharadwaj Academy. Correct? So, we are in the first module of differential calculus in the part one of my four-part series of lectures in engineering mathematics, where today we'll be learning about a very important theorem in the differentiation module, which is Leibnitz Theorem. Yes. Before we go into the formula, let us see what is the definition of Leibniz theorem. So Leibniz theorem is used to find the nth derivative of a product of two functions. Yes. Now, if I have to tell you what's the formula, this is the formula. But let's keep the formula for the people who are by hearting, correct? Because we have to understand how to solve questions on Leibniz theorem. This formula, I think you can mug up, right? Because you're engineers. So, but let's understand Leibniz theorem in a better way. So I would say that Leibniz theorem is nothing but an extended product rule for differentiation. Yes. What is the product rule of differentiation? Yes. If you have a function which is the product of two independent functions, u and v. Yes. So the product rule is nothing but differentiate u, keep this as it is, and keep u as it is and differentiate the other one, and you just have to add them. Yes. Let us take a quick example. If you have a function x square into e power x, apply product rule on this, what will we get? So differentiate the first one, keep it as it is. So I'll get 2x e power x plus. Now, if I differentiate e power x, I'll get e power x itself, but you have to keep this as it is. So this is what we'll be getting. Correct? Yes. So this is our product rule. Now, let us extend the product rule into the next derivative, which is the second derivative. So this is what we get. Can you see here? You are having here u2v plus 2 u1 v1 plus u v2. Now, if we differentiate this once again, you will get this. This is a third derivative of uv, and this is the fourth derivative. Yes, I want you to differentiate these individually by applying the product rule for these individual terms so that you can get these expressions. Try it. You'll be able to get these results. For now, we will just proceed with this. Okay. Now, do you know that in order to obtain the fourth derivative, I personally did not do this derivation. Correct? I personally did not derive this, but I used a technique. What is this technique? Yes. Now, if you carefully observe the subscripts of these numbers of u and v, correct? Can you see a pattern? Yes. As you can see, this is the n, right? So we are finding out the nth derivative where n is equal to 4. Now, can you see here u ranges from n to 1, n to 1, and then to 0. What do you mean by 0? I'll tell you. Yes, n is 4 here, right? It will become 4, 4, 3, 2, 1, and 0. You should not forget 0 here. What do you mean by 0? U subscript 0 means you have to write u as it is. You should not differentiate the function u. So what will it get us? So 4, 3, 2, 1, and 0. What about v? Yes, you have to start v by keeping v as it is, which means v subscript 0. 0, 1, 2, 3, and 4. As you can see, u goes from n to 0 and v goes from 0 to n. This is in the decreasing order and this is in the increasing order. Yes, decreasing order of what? With respect to n. This is what we have to primarily know and understand here. Correct? So even if I have n is equal to 6, you will start from u6 v means v0, nothing. You have to keep the v function as it is. Then you'll get next as u5 v1, 0 to 1, right? And this will be from 6 to 5. As you can see, from n to 0 it is decreasing and v is increasing from 0 to 1. Yes. Now u and v are done, correct? U and v are completely resolved. But what about these coefficients? Can you see here the coefficient of here is 1 and 1. Now can you see a pattern here? The starting coefficient and the last coefficient are 1 each, but the middle, they follow a pattern. Now what kind of pattern is this? Correct? This pattern is what we call as the Pascal's triangle. Yes, this Pascal's triangle is a unique method where instead of using NCR formula, we'll be using the Pascal's triangle. But how do we obtain the Pascal's triangle? In every row, it starts from 1 and ends with 1. Can you see here? Yes. And the next number is obtained by adding the numbers of the previous row. 1 plus 1, 2, 1 plus 1 plus 1 is 2 here. Yes. And here 1 plus 2 is 3, 2 plus 1 is 3, and here 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4. Yes. So as you can see, now what we have to do is, if it is nth derivative, yes, if it is the nth derivative, the coefficients will be nothing but the numbers in the nth row of the Pascal's triangle. Is the numbers will be nothing but the nth row of the Pascal's triangle. Yes, for example, if I ask you the sixth derivative, you have to take the sixth row. So why don't we all put it together by solving a simple example problem? Yes, let's take a very simple one. Find the sixth derivative of the function x power 6 and e power x. First, let us find out what will be the format of the answer. Yes, this is how your format would be like, correct? Now, here, let's consider u as x power 6 and v as e power x. Yes, first of all, let us fill the directions of u and v. What do you mean by that? As you can see, u goes from what? U goes from n to 0, which means n is here 6 because we are finding the sixth derivative. This is the n is equal to 6, correct? So what do we write here? 6, 5, 4, 3, 2, 1, 0. 0 means u as it is, correct? But what about v? V starts from 0. 0 to n. That means it goes from 0. That means v as it is. V1, 2, 3, 4, 5, and 6. Now, what do we do for the constants? What do we do for the constants? Correct? Now, in order to take the constants, let's take a look at the Pascal's triangle. Yes, in the Pascal's triangle, we have to take the nth row, which is n is 6 here, right? So we have to take the sixth row. So just write these numbers here. So 1, 6, 15, 20, 15, 6, and 1. Now, if you solve them, you'll be able to get the answer. That means you have to differentiate u 6 times here. You have to differentiate u 5 times, 4 times, 3 times, 2 times, 1 time, and keep u as it is here. Correct? Let's put it all together now. Yes, let us see how. Yes. Now, since u is an algebraic function, yes, here is a list of its derivatives. This is u function. First derivative is 6 power 5. And these are the list of derivatives up to u6. Correct? Now, we know that v is equal to e power x, right? So even if you differentiate not once, not twice, but even if you differentiate 100 times, you will get v6 or v7, anything, it will be still equal to e power x because it will be the same. Yes. So if we substitute everything, this is what you'll be getting as the answer. Yes, that's it. So thank you for watching this video. Please make sure to like this video and subscribe. Also leave in the comment section on any feedback or shortcomings. Stay safe and bye.